next part of our machine learning, which is called as logistic regression. So logistic regression, although it may sound as a regression model, it is actually a classification model. That means it divides your data into groups. Suppose we have a question where we have price and y is the decision of buy or not buy. So when the price is 10, 20, 30 and 40, the buyer's decision is yes, yes, 0, 0. So where 1 means buy and 0 means not buy. So if this is the data that is given to you, then you can see here that instead of a continuous value like if we have to predict the price, this is actually a discrete decision, buy and not buy. There can be only buy and not buy, and no other value is possible. So this is called as classification. Remember that there are finite possibilities in classification. Possibility of the answer is either buy or not buy. There is no other possibility. There cannot be 0.1, 0.01, 0.9. This don't exist. There are only two possibilities. So this kind of problems are called classification problems. And classification problem, the best, first step is to try and solve them using logistic regression. What is logistic regression? So let us say that we have X here, which is the price, and Y here is whether the decision will be buy or not buy. Okay, just the same question. Buy is 1, not buy is 0. So as you look at the data, this seems to be a threshold value that although this problem is not so clear, so let us create our own problem x 0 0, and this seems to be the boundary between x and 0, where though this is y is equal to, let us say 25. Here this is 10, this is 20, this is 30, this is 40, and this is the model, linear model that separates this region from this region. So till the price x is less than 25, the y will be 0, and if x is greater than 25, then y will be 1. Okay, so this is the separator of the two classes. This is the class not buy and this is the class buy. And our purpose is to learn what is this decision boundary. This is the use of logistic regression to create a classification. How does that work? Let us say we have x as the feature and y as the prediction. So logistic regression is simply given by this formula m1 x1 plus c. So the first part m1 x1 plus c is similar to the linear regression, except there is a extra sign here, and this sign is the logistic function. And because we use the logistic function, this kind of model is the logistic regression model. So let us see what is this logistic function. The logistic function is represented by a curve which takes the shape of something like this. Here we have Z and here we have Y. We are discussing the logistic curve or the logistic function, or also it is known as the sigmoid function. If Z is towards positive infinity, then what is y dash? Y dash is, this is 0.5 and this is 0. So when Z is close to positive infinity, what is y dash? Y dash is close to 1. So if I say Z is nearly equal to positive infinity, then y dash is 1. When Z is close to 0, when Z is close to negative infinity, so we have negative infinity here. So when Z is approximately negative infinity, then y dash is 0. So here, what is Z, if you may ask? Then Z is m1 x1 plus c. That is the linear regression. Whatever is the value of linear regression, if it is greater than, you can say, if it is positive or infinity, then the prediction is 1, and if it is negative or negative infinity, then the prediction is 0. So you can think of logistic regression as converting the continuous output into a binary output, 0 and 1. So given our question may be something like this. There will be x1 and there will be y and there will be y prediction. Okay, so x1, y and y prediction. x1 can be the size of the house and x2 can be the decision of buy or not buy, and this is the predicted decision. Let us say the size is given like this, 10, 20, 30 and 40, and the decision is like this. Then we have to calculate the prediction as the sigmoid function multiplied by m1 x1 plus c. Let us say that our step 1, how will we calculate m and c? So we randomize m and c. We take m as 1 and c as 1, and we calculate what is going to be m1 x1 plus c followed by sigmoid. So 1 multiplied by 10 plus 1, which is c, which gives us 11. So z is 11. If I show the logistic curve to you, then remember z, which is 0, positive and negative, and the y prediction is given by this curve. So when z is 11, that means we have the y dash somewhere here, somewhere between 0.5 and 1. So when z is 11, y dash is given as 0.56. So we have y dash as 0.56. Then same we do for 20. When z is 20, then y will be a bit higher. When z is 30, y is even higher, and when z is 40, y is even higher. Just we have applied this formula here and followed by the sigmoid equation, which is given by this curve. So we have got the predictions, we have got the actual values here. We can see that Actual values are 0 and 1, but predictions are like this. So there is a difference, and that difference is called the error. So how is the error calculated in logistic regression? We will